Let's have a look here. How about something like this? Okay, so what we're trying to do here, I know we kind of got I got taken away in the last week, and so we've missed out on maybe doing a couple things I wanted to do. That's all right. We'll do it this week. Kind of remember where we were going with this, though. What we were trying to do is we were trying to come up with ways to solve quadratic equations, right? So our goal here is we want to get to a point where we can do things like this, where we can solve, for example, where we can solve quadratic equations. Okay? They might look like that. They might look like they might look simpler. They might look like that. But they're equations that have x squareds in them, right? And so we started off kind of talking about how to deal with problems like this, right? Where we can't use our old normal approach of just isolating an x because there isn't a single x for me to point to isolate, right? And so to get there, though, we needed to review some stuff. We needed to review some things from Algebra 1. Okay, and one of them is factoring. And we're not going to spend a ton of time with factoring, but we want to be able to do some simple factoring because it's a good strategy. So what about stuff like this now? Here we're trying to just identify the greatest common factor. It's not hard to do, but if you're not sure what a greatest common factor is, you might not know how to get started on something like this. So the greatest common factor, or GCF, remember all that is the biggest number and or variable that I could undistribute from all the terms. Always a great idea. It's always going to either give us a free solution, as we'll see a little bit later, or it's going to make our lives a lot easier. Okay, so let's look at this in two parts. Let's look at it as a number and as a variable. All right, so here's what we're faced with. There we go. Okay, so what's the biggest number by greatest common factor, right? Factors are things that multiply together, right? So the factors of 10 would be what? 5 and 2 would be factors, or 10 and 1, right? 10 times 1 equals 10, 5 times 2 equals 10, right? And then it's negative, so one of them would have to be negative in this case, right? But we're trying to find the greatest common factor. So we want to find the biggest, start off with the number part, that's going to divide evenly into all of those three numbers. What's it going to be? 5, yeah. It's going to be 5, and the rule is, because the dominant term, the term with the x squared, we call that the quadratic term. Because the quadratic term has a negative coefficient, we're always going to take the sign of that number with our greatest common factor, right? So then the answer is, all they're looking for here, if I were to factor it out, I'd get negative 5 times whatever is left over, which would be what, by the way? Negative 5 times what is negative 45? Okay. Negative 5 times what is positive 35? And then negative 5 times what is negative 10, right? Okay, and in this case, so the answer we're looking for is just that. That's what we'd enter in Moodle. That's all they want. They don't want you to write out the whole thing. They just want to know what is the biggest thing that you can undistribute. Now notice in this case that there is no x tacked onto the 10, and so we can't undistribute any variables, can we? Right? So that's our answer. Negative 5. Now watch what happens. Negative 5 is the correct answer. What if I put in 5? What does Moodle tell me? Yeah, it tells me the greatest common factor should have the same sign as the leading coefficient, so it should be negative, right? Okay. let's look at one like this. Oops, not like that. Let's look at one like, maybe like this. Yeah, there we go. Okay, something like that. So if you don't have your math notebooks out, get them out and try that one. Okay, and think of it in two parts, right? Think of the number, the biggest numerical part, right? It's the biggest number that divides into all those. And then also, what about the variable? What's the biggest power of x that I could undistribute from all three? What about the number? It's the biggest number that divides into all three. 6. Okay, so there's part of it. What power of x could I undistribute? Yeah, it's going to be x cubed. Now let's look at why that is. Somebody want to tell me why? Why is x cubed part of the greatest common factor?
Because that's the least number cubed.
Okay, because I can't take any more than that because this is our weakest term, and that's all the biggest power of x that it has to give away. I can't take more than it has to give, right? Think of what these really mean. X to the fifth is really just x times x times x times x times x, right? X to the fourth is a string of 4x's multiplied together, and x cubed is a string of 3x's multiplied together. Well, if I want to divide away or factor away as many as I can, all I could do is just take away 3 of those from each one, right? Because this one can't give me any more. So what am I going to be left with? Now, keep in mind, this is not what Moodle is asking, but later on I will be. So let's go ahead and finish this up. So what am I going to be left with? If I undistribute 6x cubed, what's going to go here? 6 times what number is 60?
10.
Let's just do the numbers first. 6 times what is 42?
7.
6 times what is 6?
1.
1. And that 1, we maybe don't even have to write probably, right? Well, maybe. We'll see. Okay, what about the x's, though? What am I going to be left with in terms of numbers of x's? Gabe, how many x's am I going to be left with in my first term if I undistribute x cubed? 2. Good. And we can see it this way, right? But that's kind of a clumsy way to think about it. There's an easier pattern that we could follow. I just know that if I multiply like bases like this, right? X cubed times what is going to be x to the fifth. When I multiply like bases, all I'm doing is adding up the exponents, right? So really, if I want to kind of put that in reverse, please put all phones or earbuds or anything away. I don't want to see any of that stuff out in class. So if I do that in reverse, I'm saying x to the fifth, take away x cubed, right? Take away the 3 from the 5 is leaving us with a 2. That's how many x's are left when I strip them away. So we're really just subtracting this exponent from each of those, right? So 7x to what power?
1.
So we just write it as an x, right? And then how many x's are left over here? Well, no, we took them all away. So we really do need that 1 there, don't we? Because that's what that last term is. It's just a 1. Once again, in Moodle, all we need for this question, if it just wants to know what is the greatest common factor, that's it, right? That's the biggest thing that we can undistribute. Okay? Questions on that?
You would just have to Moodle as 6x.
6x cubed. Let's do that. So in Moodle, we would just go, and when you see questions like this, you understand that just means that's where you can pop up the editor. Okay, so we would just have 6, there we go, 6x cubed, like so. Okay, make sense? All right, moving on. Let's try one of these. Okay, so these are the kind, let's kind of remind ourselves how we do these. We're trying to factor this quadratic. Oh, it's supposed to be an equal there. I don't know why it's not showing up. I'll fix that.
That would be the. No, I'm asking, that would be the
Okay, so we want this to equal something written in factored forms. We want this to equal something like that, right? Now, what can we do right away? Kobe, what can we do right away? Before we even start thinking about magic numbers or anything, we know what our template's gonna look like, right? I'm just gonna unexpand this. So we have to kind of think in reverse. If I were going to distribute, what would the first two terms have to be in each of those to multiply to x squared? Because whatever's there, I'm gonna distribute, right? See what I'm saying? I'm gonna distribute this one to both parts and then this one to both parts. But the only arrows, the first arrow that we draw when we distribute, whatever goes there, is gonna be times that one, right? And that's gonna give us that, right? So what do those have to be?
X.
Yeah, x and x, good, right? Because when I distribute the x times x is gonna give me x squared. So I know that much, right? Now I just gotta go find the numbers. What do the numbers have to do? I just need to fill in the blanks here with the numbers that fit this quadratic, right? What do they have to do though? They have to do two things. They have to multiply to what?
80.
Yeah, they gotta not 80, negative 80, right? They gotta multiply to this number. They gotta multiply to that one and they have to add to what number? Trevor, what number do they have to add to? Multiply to negative 80, add to. So I gotta find magic numbers that go here and here. The two numbers that go here, and this is our answer, it won't always work, but on this assignment it will. This is just practicing doing this process. They have to multiply to the constant, right? And think why, because whatever's here, this number is gonna be distributed to both parts. But when this number is distributed there, remember what that did? That number times that number gave us that number, right? So we know that the two numbers multiply to that. What do they add to?
2.
Yeah, 2, right? They're gonna add to whatever's being multiplied by x, right? So we just have to find those numbers. What two numbers multiply to negative 80 and add to positive 2?
That's 10 minus 8.
Does that make sense? We gotta find numbers that are gonna be separated. Let's have people raise their hands on these. I'm gonna kind of start calling on people. So we gotta find numbers that multiply to negative 80. So, and if they're gonna add to positive 2, think about our sign rules. If they're multiplying to negative 80, what does that tell you about the signs of the numbers? Richard, what's that tell you about two numbers if they multiply to a negative? So what would the signs of the two numbers be if they multiply to give you a negative? If they're both, like take an example, negative 7 times negative 5. If I multiply negative times a negative, what do I get? Positive. So if they're going to multiply to a negative, one's got to be negative, right? One's got to be positive, right? Because how do we get a positive answer when we multiply numbers? Either they're both negative or they're both positive, right? So if they're multiplying to a negative, I know I've got one negative and one positive. Let's go ahead and always, just to have a pattern that you can sort of depend on that's consistent, let's always put the bigger number first. Well, if they're going to add to a positive, which one dominates? The positive's got to be a little bigger, right? So that's going to be a plus and that's going to be a minus. And now we just got to think about it, right? We know that if 2 is left over, when we add these numbers up, the positive one must have been how much bigger?
About 2.
2, had to be, right? Because when we add them up, we get positive 2 left over. So then we're thinking about numbers where the positive one is 2 bigger and they multiply to negative 80. So if we wanted to just, whoops, if we wanted to just do it this way, we could say, I've got negative 80, let's make a list of the factors, right? If we, I mean, and you may, on a lot of these, not have to go through this whole process, but we'd have the positive one being bigger, so the most extreme would be that, right? Notice the trend here. I don't know, we've talked about this a little bit, but let me point this out again. If I pick factors that are really extreme, one's really big and one's really small, they're gonna add up. So if we make a column for the sum of the numbers, they're gonna add up to be really big numbers, right? We don't want that. We want it to add up to 2. So I could go way down this list. I mean, if I just continue 40 and negative 2, that's way too big, right? But if I get down towards numbers that are closer together, like 10 and negative 8, those add up to positive 2, and that gives me the right answer. So you kind of have a little bit of a clue here. You know that if this number is small, it means that the positives and negatives must be pretty close together, right? If it's really big, then they're far apart, okay, and they're going to be real extreme. So then what are our answers?
10 and negative 8.
10 and negative 8. So that's how we would write this thing, right? In factored form, it's just the quantity x plus 10 times the quantity x minus 8. Okay, try another one. Okay, try that. Everybody try that. See if you can write that. So we're filling in the blanks here. You're filling in the blanks. Last one, something like this. Okay, what about these, what about stuff like this that's pretty hard? I don't really care so much about this. This isn't going to be something that you're going to do a lot of, but let's just go through this once, just to kind of refresh how we use bottoms up. Right? So if we've got a problem like this guy, okay, so our goal here is to do the same thing with this, right? We want to see if we can rewrite this as, a product of factors. The first thing we always want to try to do is see if we can factor out a greatest common factor. So if you see a number out here in front of x squared, you always want to ask, okay, well, can I just factor that out of everything, undistributed? But I can't, right? 3 doesn't go into these other numbers. So we're stuck with this. So remind me then, steps for, yes, what do we do first?
You have to multiply 3 on the 7.
Good. So we got to multiply a times c, because this is really just the form ax squared plus bx plus c. Very good. So we're going to do ac equals 3 times 7, which is 21. So we need numbers that multiply to ac and add to what?
21. Or 7.
No,
10.
10.
Add to 10.
Add to b, right? So they're going to multiply to ac and they're going to add to b. So what are the signs going to be if they multiply to positive and add to positive?
Positive.
Both positive, right? So we know that we're going to get, our numbers are both positive. And what would they be?
7 and 3.
7 and 3. Okay, so we know that our magic numbers are 7, positive 7, and positive 3. Okay, next layer. What do we do next with this?
Bottoms up.
Okay, bottoms up. First step in bottoms up. Reese, what do we do? You remember? We're going to start off with the way we always do, right? What goes there and there?
X.
X. Okay, now what?
Signs.
Say it again.
Signs.
add the signs were both positive, very good, okay. Okay, something else, somebody pitch in here, what else, what numbers do we start with there? 7 and 3, right? We just start with 7 and 3. Okay, so we add a 7 and a 3, but there's a difference. This is where we're different than what we've done in the past. What do we divide those numbers by?
3.
No. Oh, yes, sorry, 3. Yeah, we divide it by the number that's up front, which is 3, right? Okay, so that's where we start to, bottoms up starts to change things. Okay, now, really from there, it's pretty simple. What do we do with these fractions?
You do, if it divides.
Okay, so we want to simplify, we want to reduce if we can. Can we reduce 7/3?
No.
No, we're stuck with 7/3. 3/3 reduces to 1. Okay, so we can write then, this one we're stuck with. This one becomes x plus 1. So this factor's done, right? If it reduces to a whole number, or an integer, could be negative, then we just leave it. But what do we have to do in this case where the fraction didn't reduce?
3 goes through the x value.
Yeah, we go bottoms up. Whatever's left in the denominator on the bottom goes up in front of the x, and that's our answer, right? So then we just end up with
3x.
3x plus 7 is our first factor times x plus 1. On a test, how could I check and see if I'm right?
Just put it in the column.
Yeah, just distribute it, right? Distribute the 3x to both terms, distribute the 7 to both terms, add up all the like terms, and I should get that, right? If I don't, I made a mistake. So you could know if you got this one right before you ever turn it in, by just undoing your work, right? Just distribute it. Okay? That's it. I realize that's a lot of stuff. It's Algebra 1 stuff, but it's not new, but you really got to kind of crank through that assignment, and let's see where you are. Okay, only thing I want to, how much time we got?
8 minutes.
Not much. Okay, I want to show you just one thing today, really simple. And I'm going to give you another review assignment. We're not really jumping into anything new yet. Okay. What I want to review with you today, that's going to be really important in the stuff we're going to start talking about tomorrow, is simplifying radicals. Okay, so I want to know, for example, how do I, in fact, we can even be more specific. We're just simplifying square roots. So what if I've got something like, for example, the square root of 50? Now, our goal, when we're simplifying radicals, our only goal is to get as much of the number as possible outside of the radical. So we want to end up with the smallest amount of stuff stuck inside the radical, right? Well, how do we do that? Okay, we're going to take advantage of something. We know that the square root, here's the property we're going to use. We know that the square root of a product of two numbers can be split apart into separate square roots. Square root of A times the square root of B. So what we're looking for then, we're just looking for factors of this number under the radical that are perfect squares. Okay, so let's make a list of perfect squares. And this is one of the things that you're just going to have to know. You have to kind of memorize these. And like I say, I'll figure out some tool to put on Moodle that'll help you with this stuff, all right? But then we'll even this will be like a freebie. I'll literally give you a test rating here for just demonstrating to me that you know your perfect squares and your math facts. So that's pretty simple. I mean, there you got a test grade in Algebra 2 for just getting this down. You may already have it down, but if you don't, it's something I really want you to do. Okay, so 2 squared is what? 4, okay. 3 squared is 9. 4 squared is
16.
5 squared is
5.
6 squared is
36.
49 squared is good. 49.
56. 64.
8 squared is
63.
64. Where are we? 9 squared?
81. Easy. 100.
Okay, and if we go a little bit further, let's just see, let's go to 12. So 11 squared,
121.
12 squared,
144.
that's probably far enough, right?
Yeah.
Rarely we're ever gonna need to go further than that. Okay, so well, all we're looking for here is we want the biggest possible square, perfect square that divides into that number, if it does. Well, what is it?
25.
25. I'm gonna give you a little hint on how you can do this, how you can make this an easier search. You know that you'd always look at the number itself. What if that was like the square root of 36? What would the answer be? 6, right? Then it would just turn into an integer and we'd be done. If the number inside were a perfect square. But if it's not, all you'd ever have to do is start with half of the number, right? There's no reason to look for anything bigger than that. So half of 50 is 25, right? So we would just start at 25 and work our way down. Well, 25, we hit the jackpot, right? 25 is a perfect square. So we could rewrite this then as the square root of the perfect square. We always put that first, right? And then times whatever we're left over. 25 times what is 50?
2.
2. So that one goes second, right? And the reason we do that is so we can trade the square root of 25 for what? 5, right? Because the square root of a perfect square is just an integer, a whole number, right? So we're left with 5 radical 2. So let's try a couple of these in your notebook. Try this one. What's the square root of 27? Okay, try that one, and then after that, try square root of 10. Let me do one thing real quick. I'll go back and let me grab this list for you.
Oh, I didn't look at that.
Okay, there's your list. You can reference if you want it. For now. Okay, real quick. Haley, is there a perfect square that divides into 27? There's not? Anybody find one?
9.
Oh, 9 does, right? 9 goes into 27. So I could rewrite this then. Caitlin, what's going to be left over? If I break this into 2 square roots, the perfect square is 9. What number goes in there?
3.
I was asking, okay, does that make sense? Right? Because 9 times what is 27? And so how would we write this then? What's our final answer going to look like? 3 radical 3. So we met our goal. We got the number inside to be much smaller than 27. What about this one here? Is there a perfect square, a perfect square that divides into 10?
No.
There's not, is there? Or if you think about it, 10 is not a perfect square. Half of 10 is 5. Well, so the only possibility would be 4, and it doesn't work. So how do we write this one?
5.
That's it. It's already simplified. Yeah, we can't take anything, so we just write it as the square root of 10. Okay? That'll get you going. I'm going to talk about how we simplify the square root of a fraction tomorrow, and then I'll let you work on this stuff. All right.